Today we are looking at graphing systems of inequalities. The way that graphing systems of inequalities works is we're going to be presented with two linear inequalities, and our job is that we graph them both separately but on the same graph. And their solution is where the shadings overlap. Where they overlap is where the solution is. So let's look at this first example. Y is greater than negative x plus 2. And y is greater than or equal to 2x minus 1. So we'll start with the first, y is greater than x plus 2. So we start at plus 2. And we have a slope of negative 1, so we'll go down 1, back 1, down 1, over 1, or up 1, back 1, up 1, back 1, etc. We have greater than, so it's going to be a solid, sorry, not a solid, it's greater than, so it's a dashed line going through the whole graph. And if we look at our test point, 0, 0, again my favorite, do we look, is 0 greater than 2? No, it is not, so we're going to shade away. Now, for systems of inequalities, I love using colored pencils to shade. I shade with colored pencils. Why? Because when we overlap, we get to see that new color. That's their solution. So since we said it was false, we're going to shade from the line away from the test point, and we're going to shade this half plane here. So I look at my next example, y is greater than 2x minus 1. I go to minus 1. I have a slope of 2, so I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, 2 over 1, up 2 over 1, etc. Down 2, back 1. And since it's or equal to, I'm going to have a solid line. And I look at my test point, 0, 0, and I say, is 0 greater than or equal to negative 1? You bet it is, so I'm going to shade from my line toward my test point. And this time I'm going to use red to shade over here. And I can then see that, this area of purple in here, this area in here of purple, and I might, go over it again with my colors again, so that I can really see this area that overlaps right here in the middle. That is my solution to this system of inequalities. The system of inequalities, where is it that y is greater than negative x plus 2 and y is greater than or equal to 2x minus 1? In that zone. So if I look at y is less than 2/3 x minus 1, y is greater than negative 2/3 x plus 3. Remember, I do each inequality completely by itself. I do all of the first thing, then all of the second. So I start at minus 1. I have a slope of 2/3, so up 2 over 3, up 2 over 3, 2 over 3, 2 over 3, or down 2, back 3. Since it's just less than, I have a dashed line. Hopefully the process of graphing these lines is review from chapter 5. I look at a test point. I'm going to say 0, 0 is 0 less than negative 1. No, it is not, so I'm going to shade away from that test point of 0, 0 down yonder. I look at my second line, I start at plus 3. I have a slope of negative 2/3. Yes, these lines intersect at a nice even point, but we don't really care. We're not looking for that exact point of intersection. We are looking for the areas of shading that overlap. So we have a solid line because it's or equal to. I look at 0, 0, and I see, is 0 less than or equal to 3? Yes, it is, so I'm going to shade beneath or from the line away or towards the test point, since it's true, sorry. From the line towards the test point, which means I'm shading this region, and we see my solution is where it overlaps right in here. Now, we may have to rearrange a little bit before we can graph. If we have x plus y is greater than or equal to -2, or y is less than -3. I need to subtract my x on both sides, so I really have y is greater than or equal to -x minus 2, and y is less than -3. So I start at -2, have a slope of -1. I have a solid line since it's or equal to. And I look at 0, 0, and I say, is 0 greater than or equal to -2? Well, it turns out that 0 is, in fact, greater than -2. So I'm going to shade in this direction. Now I look at y less than -3, so I go to -3. And since it's y is that, we have a horizontal line through -3 that just so happens to be dashed. And I look at those values less than -3, so I think, is 0 less than -3? No, it is not. I'm going to shade away from the test point of the origin, down beneath. Lots of fun coloring. We have this purple region as our solution. Go over it again so it's purple. Now, here we have to rearrange again. So when I subtract, so I have 2x plus y is less than 3. 2x plus y is greater than -3, so I subtract 2x, actually in both of them, and get that y is less than -2x plus 3, and y is greater than -2x minus 3. So I start with my top equation, plus 3, slope of -2, and I go up 1 over up 1, or sorry, up 2 back 1, or down 2 over 1. Since it's less than, I have a dashed line. I look at 0, 0, and I say, is 0 less than 3? Yes, it is, so I'm going to shade from my line toward the test point in this half plane here. Now I look at my next line, y is greater than -2x minus 3. I start at minus 3. Careful with your shading so you can still see I have a slope of -2. So I go like that. Again, I have a dashed line. And I look and I plug in 0, 0, and I can say, is 0 greater than -3? Yes, it is, so that's true, so I'm going to shade from my line toward the test point. Now, what I hope you notice about this shading is that our solution here is this little wedge in between the two lines. This little wedge in between is where the shadings overlap, and so this little sliver is our solution. Looking at our practice problems worksheet, if we look, the first one asks us to sketch y is greater than or equal to x plus 2, and y is greater than or equal to 4x minus 1. So I start at plus 2, I have a slope of 1, up 1 over 1. I see that this is going to be a solid line. If I look at the test point 0, 0, I say, is 0 greater than 2? No, 0 is not greater than or equal to 2, so I'm going to shade away from the test point in this half of plane. When I shade my other one, -1, slope of 4, 1, 2, 3, 4 over 1, or down 1, 2, 3, 4, and back 1. Since it is also or equal to, I will be doing a solid line. And I look at 0, 0, and I ask, is 0 greater than or equal to -1? And yes, it is, so I'm going to shade from the line toward the test point. Which leaves my solution being this corner over here. And that is our solution to this system of inequalities. Use colors. Make sure the ones that blend well, though, not like light blue and dark blue, but maybe red and blue, yellow and green. Fun colors like that. So have fun doing some systems of inequalities.